So I'm going to be talking about planets, and by planets I mean both planets in the solar system and exoplanets. Now I'll start with planets in the solar system. Planets in the solar system, usually you've probably learned them as Mercury, Venus, Earth, Mars are the terrestrial planets, and then the gas giants are Jupiter, Saturn, Uranus, and Neptune. Scientists have sort of moved away from that because because some of these planets are so different that we instead say Mercury, Venus, Earth, and Mars are terrestrial planets still, but then we split Jupiter and Saturn into gas giants, and then Uranus and Neptune into ice giants. Since they are Jupiter, Saturn, and Uranus, and Neptune are very different compositions of chemicals, they don't really aren't really similar in that sense. But Mercury, not Mercury was sort of a oddball. Named after the Roman god of messengers, speed. He had winged sandals. Hermes was his Greek equivalent. But it was visited by the Messenger probe back in the early, I think it was either the 90s or the early 2000s. I have to look that up. But it it's closest to the sun, but it's not necessarily the hottest because Venus. A lot of probes went to Venus before we figured out that we can't do that. They're look up the Mariner probes. Those are usually the ones that go to Venus. Those are the ones that went to Venus. Because Venus has a thick cloud of it has a thick atmosphere, which is caused by a runaway greenhouse effect, which is what climate change is now. It's the climate change now is sort of the start of what's called a runaway greenhouse effect, and what happens is light is captured by all the dense, thick atmosphere of Venus and is trapped there and can't be released back out. So Venus is like extremely hot, about 900 degrees Fahrenheit ish. Not sure what that would be in Celsius. Like, I'm trying to start using Celsius. But then we got Earth, which is Earth. So yeah. Then not a planet, but incredibly interesting, the Moon, which I will talk about in a different video. And then obviously Mars, which obviously we've explored a lot because Venus and Mars both we think may have been habitable for life earlier on in the solar system before Earth was. Just due to what we found there, we think these we've seen valleys on Mars that we think may look like water erosion, such like stuff like that. Which is why we're thinking about maybe going to Mars in the future. NASA plans to go to Mars in 2036 with the Artemis program. Artemis program actually will start. Probably seen about it if you follow that stuff. But in 2021, they will send an unmanned probe back to the moon. It will just circle the moon, and then 2024. It's either 2023 or 2024. For some reason now it's evading me. They will send a manned probe back to orbit the moon, which will be the first time that people have left low Earth orbit since Apollo 17 back in 1979. Anywho, then we get to Jupiter, which is the biggest planet in the solar system. Interesting thing about Jupiter, I will say later in this video. It's very interesting. But Jupiter was probably the first planet formed. It's currently being orbited by Juno, which is a space probe. Saturn used to be orbited by Cassini before Cassini killed. Basically, what Cassini did was, when probes aren't useful anymore, scientists try to avoid what's called forward contamination, which is introducing living organisms into a sterile alien environment, say a moon or something like that. So they what they do is they plunge the spacecraft into the atmosphere of the large body. This is mainly just for gas planets, though, because and then it just burns and just is crushed in the atmosphere. That way, no germs are doing anything in that atmosphere. Uranus and Neptune, we don't know much about them. The only probe that's visited them was Voyager 2 back in the 80s. So, and that was built in 1970, in the late 1970s. So, even still, we're all always thinking about going back there, but kind of far away. Even for light, it takes 4 hours to get from the sun to Neptune at the speed of light, fastest speed there is. So quite far away. Um, Now for exoplanets, everybody is like, oh, exoplanets. What's the deal? So the deal with that is looking for planets that are like Earth, or just at planets outside the solar system, to just for discovery of what their atmosphere might be like, which you can find out chemicals in a planet's atmosphere using spectroscopy, which is really cool. Finding out what uh, type of planet they might be, size of the planet and stuff. This and usually how exoplanets are founded through transits, which is basically, say you have light. You got a star. If a planet goes past the star, then a little bit of that star's light is no longer reaching uh, the observer, basically. And you can see, if you measure the light, you can see sort of a dip where when the planet comes by. Uh, it's sort of like a solar eclipse, so the starts blocking out the sun. Less light gets through, and then and then it's all dark. It's sort of like that, but on a much more like fine-tuned scale. Since it's only a small planet, moving across like the size of your fingernail, trying to move across the, you know, say like your entire field of view. So it's very small with a very large star. So it has to have Kepler, the space probe Kepler, just I think it just ended operation, and it found many exoplanets, thousands of exoplanets. So it was a very famous one for that. Um, James Webb Telescope. Whenever that gets up, it's a joke because the James Webb Telescope it was supposed to go up in 2015, and it still hasn't gone up. So everybody's like, the whole joke in the astronomical community is like, wow, 1 millennia later, the James Webb Telescope is finally up. That's the whole joke meme thing. Uh, but for exoplanets, we found very interesting things. For instance, most Jupiter-sized planets, and we were not expecting this, orbit at about the orbit of Earth to Mercury to Earth, that close to their star, their home star, their sun. And we were not expecting this because we thought all the gas would just evaporate that close, but apparently not, and they have very quick orbits. Other thing was we haven't found a lot of planets like Earth. Usually they're either much denser or much bigger, as in they're either larger or they're much denser, causing much more gravity uh, with them. And that's basically the deal with exoplanets, is that we're seeing like we can't live on Earth forever. The sun will burn up. We'll die eventually. But if we can look at these things beforehand, we could either gain some new insights or just possibly new worlds that we could visit in the future. Whenever we get faster than light travel, like in Alcubierre Drive or something like that. So yeah.